Welcome to WB Institutions. Today's topic is frequency division multiple access. So under communication systems, multiplexing, multiple access, these topics seem to be a very important one. If you're really preparing for any of your competitive exams like TRB or any of that, this segment seems to be very important and you can find repeatedly asked questions from this particular segment. So, if you verify any of your previous year question paper from TRB, you might find a single question, at least a single question from this segment. Okay, so please do concentrate over here. In this particular video, I'm going to discuss about the frequency division multiple access. In my future video, you may expect the other multiple access divisions also. Yes. Without any further ado, we'll get into the video. Frequency division multiple access. We have to know, before discussing about this, we have to know what is multiplexing and what is multiple access, which seems to be a very familiar word, and it also looks like very similar also, but it is totally different. We have to know what is multiplexing, what is multiple access. Then only we can know clearly about this particular segment. Okay, what is multiplexing? Okay, you can see a diagram over here, right? You can see some 5 systems. Let me consider these 5 systems as a single users. Okay, this is going to be my user 1. Okay, I'm going to consider this particular system as my user 2, and this is going to be a 3, and 4th system is my user 4. Okay, these 4 users are communicating together to a particular channel, okay, or a system. Okay, from that it is got these are the 4 different signals. Got it? These are the 4 different signals, okay, are got communicated together to a single system, and it is got transmitted into a single signal. This is very important. Single signal. Okay, single signal. Yeah. This processing is called as multiplexing. Okay, with the help of, what is this maxima? Mux is nothing but the abbreviated form of multiplexing. Okay, so with the help of mux, these different 4 signals are got combined together into a single signal, that is a one signal, and it is got transmitted in a shared medium. This process is said to be a multiplexing. So you can find a definition over here. Multiplexing is a method by which multiple, that is different, many, multiple analog or digital, the signal can be an analog signal, so no restrictions. Okay, it can be your analog signal or it can be your digital signal, are combined together to form a single signal over a shared medium. This is what called as a multiplexing is. Yes. Now, what is multiple access? Okay, now you can see a baseband signal over here. I'm going to consider this tower as a baseband signal. Okay, this is going to be your baseband signal, and this is your mobile signal. Okay, mobile band. Okay, these area, the particular different users are the mobile bands. Okay, with the help of my Wi-Fi or any of your I'm going to consider Wi-Fi as an example. Okay, from a single baseband, the signal is transmitted to multiple users. In order to enhance this transmission, I need a channel which avoids, say, inter-symbol interference between the different frequency or different users. Okay, so that particular channel, I need a particular channel. With the help of that particular channel, it can be transmitted to the single signal. Say from a single baseband, the signal is transmitted to multiple users, okay, without interference. This, to enhance this, I need a technique. This technique is said to be a multiple access technique. With the help of this, I can use a channel which transmit to a multiple user from a single baseband without inter-symbol interference. Okay, you can see a definition over here. Multiple access is a use of multiplexing technique. So this is going to be a very noted word for what is that? Multiplexing. The application is said to be multiple access. Okay, so it's a technique to provide communication service to multiple users, yes, over a single channel. With the help of a single channel, it is transmitted to a multiple user, right? This technique is said to be multiple access technique. Clear? So it allows for many users at one time by sharing a finite amount of spectrum. Yes, with the help of a single channel, or a single channel, single signal is get transmitted to multiple user with the help of a single channel is said to be your multiple access technique. Clear? So under multiple access, today we are going to see about frequency division multiple access. Okay, before that, what is this multiple? Multiple means that many users, right? Okay, how these users are got separated, or how they are defined from each other, how they are unique from each other? It's a very big question, right? So we'll get the answer under this frequency division multiple access. For that, I'm going to draw a diagram over here. Okay, this is going to be a frequency, and here time I'm going to draw in a radio frequency different bands. Okay, see, this is going to be my channel 1, okay, channel 2 and channel 3. Okay, imagine I have got 3 different users. Got it? 3 different users. In this frequency division multiple access, each of the 3 users are got allotted with different channels. Means that, for example, the user 1 may be allotted with this particular channel 1. For the user 1, this particular channel 1 is allotted. In that, we'll be having particular frequency ranges. Okay, channel 2 is maybe allotted for user 2, and channel 3 is allotted for user 3. Okay, see here, the frequency range over channel 1 is different from 2 and 3. The frequency range of channel 2 is different from 1 and 3. The frequency range in the channel 3 is totally different from channel 1 and 2. Means that what I'm trying to say that each channel is said to be unique. They are not similar to each other. Clear? In this particular way, all the users are got differentiated. Means that the frequency is got divided between the channels, which is got allotted for different users. Okay, from this you may get a doubt. Means that each, I have told you that channel 1 is allotted for user 1, channel 2 is allotted for user 2, and channel 3 for user 3. Maybe it is predefined. You may have that doubt. No, it is not predefined. According to the necessity of users, the frequencies are got allotted to the users. Clear? According to the necessity of the users, the frequency from the baseband is got allotted to that particular users, which won't coincide with the other users. Clear? This is how frequency division multiple access work. Clear? Now, here you can see some gap over here, right? You can see some gap. This particular gap, I'm going to call this as a God band. What is the use of this God band? This is placed in order to avoid the inter-symbol interference between the other users, between any of the 2 users or many users. Got it? In order to avoid inter-symbol interference, the God band is used. See, this is very important. God band should be placed perfectly. If the God band is very less, there is a chance of interference between the users. For example, see, I'm going to consider user 1 and user 2. In between if the God channel is very less, okay, if we are going to get a God channel very less, then you may get a symbol interference error between the channel 1 and channel 2. So in order to avoid that, we are getting a God channel over here. Clear? Yes. So this is going to be your technical diagram. Under that you can see a frequency. This is going to be your time and power. Okay, the blocks which you are seeing is going to be the channels, a different channel. Each user allotted a different subband or a channel. Already have explained here, right? So this is going to be a technical diagram. Yes, this is going to be a one channel, this is going to be a second channel, and third. The gap in between them, see, this gap is said to be your God band, which I have explained right now. Got it? So yes, hope you're clear with this. Now we will check the pros and cons of frequency division multiple access. Yes. So first point, frequency division multiple access allocates separate frequency band or channel for separate users. That we know very clearly. So each users are unique with a unique frequency band or a channel. That we know already, right? Okay. The first point is very much clear. Yes. The bandwidth of frequency division multiple access channel is around. So what you are stating that each particular user will be given with a maximum frequency range of 30 kilohertz. Okay, this is going to be the maximum frequency range which is given to each user. So they are calling this a frequency division multiple access as a narrow band frequency channel. Got it? They are called as narrow band frequency channel. Yes. Okay, so my next the second point is also got over. Now, no equalization is required due to the lack of inter-symbol interference. Means that because of the presence of God band, the inter-symbol interference is got neglected. Since there is a lack of inter-symbol interference, the equalization technique is got omitted in this particular frequency division multiple access. Okay, if the God band signal is not perfect, see, the God band is not perfect and it is very small, then inter-symbol interference may occur between the channels, and that results the equalization technique. So it is very important to take care of our God bands. Okay, next is frequency division multiple access is continuous transmission. See, in this again I'm going to draw this channel. Okay, see, frequency and tan. Okay, this is going to be a particular frequency band which is allotted for a channel 1, right? And this is going to be a particular channel which is allotted for channel user 2 or channel 2, right? Now the communication which was happening in this particular channel 1 is continuous. There is no break in between them. It is very continuous. So here it is stated that a frequency division multiple access is continuous transmission system. This represents the transmission between the channel, within the channels. Okay, communication within the channels. Among the channel 1, the communication is very continuous. In the channel 2, the communication is very continuous within the channel. So they are stating that where it requires less overhead compared to the time division multiple access. Overhead means that the synchronization or the framing of bits is less when it is compared to the time division multiple. This I'll explain when we are dealing with time division multiplexing. When you consider here, because of its continuous transmission, the synchronization or else the framing of bits is less. Got it? Got it? Now, final point. Frequency division multiple access uses duplexer. See, it is a bidirectional communication, bidirectional transmission. Got it? Duplexer means bidirectional. Bidirectional, since both the transmitter and the receiver operates at the same time, means that transmitter will transmit data and the receiver will receive data. It is operating in the bidirectional pattern. Okay, this results in the increase of cost in the FDMI. This is going to be a disadvantage when you get into this frequency division multiple access. Hope you understand the topic clearly. This seems to be very important. It is a very short topic, but it is a very important one. In my further videos, you will be seeing about the next techniques like time division multiplexing, code division multiplexing. So stay tuned. Thank you.